These are the notes for 10.3. We're going to be simplifying radical expressions. So we just did a section 10.2 on rational expressions. We're done with that. We're not going to use rational expressions for any of these problems that we're working in 10.3. Okay? So when you have radicals, and that's what we're back to using, the product rule, or in other words, we can multiply using radicals as long as the indices are the same. You can multiply a cube root by a cube root or a square root by a square root, and you can do that very easily by just multiplying what's underneath. So in other words, root 3 times root 2 is simply the square root of 6. The cube root of 32 times the cube root of 2 would be the cube root of 32 times 2, which is 64. Now, but wait, that can simplify because we know the cube root of 64 is 4. I can multiply these because the indices are the same. This would be the fourth root of 6 times 3 is 18x cubed. So you can multiply them. Well, guess what? Quotient means divide. You can actually divide them too. So we actually already used this a little bit when we did our 10.1, but if I want to take the nth root of a fraction, I just take the nth root, whatever it is, square root, cube root of the top, over that nth root of the denominator. So in other words, the square root of 25 over 16 is the square root of 25 over the square root of 16, which is just 5/4. The fourth root of 3 over 16y to the fourth, I'm going to split it up. It would be the fourth root of 3 over the fourth root of 16y to the fourth. Well, that would be the fourth root of 3 over, this simplifies, the fourth root of 16 is 2, and the fourth root of y to the fourth is y. And that would be considered simplifying. So radicals can simplify in another way as well. There's a rule that you never want to leave a perfect square under the radical. If you leave a perfect square under the radical, it is not considered simplified. So it says look for a factor that is the largest, in this case, perfect square. So here's what you do. You think to yourself, what is a perfect square? Now remember, our perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, and so on. Those are our perfect squares. What is the biggest one of these perfect squares that divides evenly into 18? Well, 9 divides into 18. So I can actually split up the square root of 18 into the square root of 9 times the square root of 2. I just used my multiplication or product rule backwards, and I split it up. But what's the square root of 9? That's a perfect square. It is 3. So the square root of 18 breaks down into 3 times the square root of 2. This would be considered simplified form. Well, same type of thing with the cube root. Now remember, your perfect cubes are 1 cubed, which is 1, 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed is 64, and so on. So is there a perfect cube that divides evenly into 40? Absolutely there is. It is 8. So I can break up the cube root of 40 into the cube root of 8 times the cube root of 5. But I know that the cube root of 8 is 2, so the cube root of 40 simplifies into 2 times the cube root of 5. So from here on in, you're going to be expected to always simplify your radicals if possible. All right, now let's throw some variables in there. Well, first of all, I happen to know, and you know, that the square root of 81 is 9. So I can simplify this right now into 9 and leave the square root of x to the 5th. Now, remember x to the 5th can be simplified. I'm talking about the square roots. So would you believe, or would you agree that I could, I'm just going to use some scrap here, change that into x to the 4th times x, because x to the 4th is a perfect square. What is the square root of x to the 4th? It's x squared. So it splits up into x squared root x. So this would become 9x squared times the square root of x. Now I want to show you a shortcut, and this will always work. The index here is a 2. It's understood. 2 goes into 5 twice, so that means that 2 x's come out with 1 left over. I'm going to do another example right to the right of this. I'm going to throw an extra 1 in with another example of that before we change the index. What if I had the square root of 24, excuse me, x to the 6th, y to the 7th, z to the 9th. That's a hard one. All right, so here's what you would do. First, work on the number. Well, 24, what's the largest perfect square that divides into 24? It's 4. So that becomes the square root of 4 times the square root of 6. So the square root of 4 is 2 is going to come out, and the root 6 stays underneath. All right, so that's just the numbers. Now let's use that rule that I just taught you, that little trick. Remember, there's an understood 2 here. So what's the square root of x to the 6th? Well, 2 goes into 6 3 times, so x to the 3rd is going to come out with none left over. So you're done with the x's. Let's do the y's. 2 goes into 7 3 times with 1 left over. And how about the z's? Well, 2 goes into 9 4 times with 1 left over. Sorry, I couldn't put that z to the 4th right in there. So that would be your final answer. And the nice thing is this little trick works whatever your index is. So now if we go and if we do this problem right here, well, let's first of all, remember it's the cube root of 24. So we know that that splits up into the cube root of 8 times the cube root of 3, because 8 divides into there evenly. So the cube root of 8 is a 2 is going to come out and a 3 is going to be left underneath. Hopefully everybody's okay with that. Now let's do the variables. Well, 3 goes into 9 3 times with none left over. So an x cubed is going to come out. It's a perfect cube, x to the 9th is. Nothing's left underneath. For the y's, 3 goes into 4 1 time with 1 left over. And you are done. All right. All right, so I want to show you something here. So look at this one with the fraction. Do you remember that I could actually also write this as just the square root of a single fraction? Now your question might be, well, why would I want to do that? Because I can reduce this fraction now, and that might make my life a little bit easier. What can I divide out of both 80 and 5? Well, a 5 will divide into both of them. 5 goes into 80 16 times, over 5 goes into 45 9 times. Now, let's split it up again. The square root of 16x over the square root of 9. Do you see what reducing that by 5s did? What is the square root of 16? That's a 4. That's going to come out. Now the x can't come out. And then what's the square root of 9? That's a 3. So in other words, you can cancel within two radicals. Let's do the same thing here. We're just going to kind of work our way across. So this would be 5 times the cube root of 40 x to the 5th, y to the 7th over 5y. So now we can go ahead and we can reduce inside this radical. So there's still the 5 left in front. That's this one. Well, if I simplify, the 5 will go into the 40 8 times. The x to the 5th is going to stay the same, but look, this y will cancel into y to the 7th, leaving me with y to the 6th. So this fraction reduced into here. All right, well now let's see what we can do. That 5's going to stay outside. So the cube root of 8, that's a perfect cube. That's 2. So a 2 is going to come out and get multiplied by the 5. Nothing left underneath because it's a perfect cube. 3 goes into 5. 1x is going to come out with 2 left underneath because 3 divides into 5 once with 2 left over. 3 goes into 6 twice with none left over. So that means a y squared is going to come out. Y to the 6 is the perfect cube. So if I just simplify the outside, oops, not x squared, it's xy squared. This will be my answer. All right, so when you do radicals, there are two formulas that always come up. And yes, you have to know and memorize both of them, so please do that. First one's the distance formula. And what the distance formula does is it finds you the distance between any 2 points, x1, y1, x2, y2. So it's just a matter of plug and chug. So in this first example, if I want to find the distance between these 2 points, let's label this one x1, y1, and this one x2, y2. And I'm going to plug it in. So it's the square root of x2 minus x1, watch your signs, plus y2 minus y1, and that's going to be squared. Literally plug and chug. So let's see, -2 minus -1, that's going to be -1 squared is 1, plus 6 minus 3 is 3 squared, which is 9. You get the square root of 10. Now, if that reduced, you would always be expected to reduce it. For example, if it was the square root of 24, you'd reduce it to 2 root 3, okay, or 2 root 6. So just make sure you always reduce your radicals when you're looking at your distance formula. So that's one of the formulas. You've seen these before. The second formula is your midpoint formula. Your midpoint formula finds the midpoint of 2 points, so the point directly between or in the middle of 2 points, x1, y1, and x2, y2. So here's the midpoint formula. So basically you add the x's and you divide by 2, and you add the y's and divide by 2. You find the mean between the x's, like the average, and find the mean between the y's. All right, so here we go. So here we want to find the midpoint of the line segment that joins these 2 points. So here's my x1 and my y1, and here's x2, y2. So my midpoint would be equal to, add the x's, so that's -3 plus 1, divide by 2, and add the y's, that's 3 plus 0, divided by 2. So the midpoint would be -3 plus 1. Well, that's -2 divided by 2 is -1, and then 3/2. So I have the graph here just so you could kind of look to see a visual. So if I have the point -3, +3, let's say that's P, and if I have the point 1, 0, that's Q. And if I look at the segment that joins those two, it says that the midpoint, or the point right between those, is -1, 1.5. Do you see that that's right there? We'll call it M. And it is exactly halfway between. So there's the midpoint formula.